Hello, today I want to talk about 230 volts AC or alternating current in vans. How we get it via, for example, inverters and hookup or shore power. By that I mean camping sockets or external sockets on houses you might find. Anywhere where you can plug up your van to the grid. I also want to discuss reverse polarity and a bit what that is, why it might be a problem or why it might not. So in short, reverse polarity is basically the two wires, if you have two wires, switching places, so you get the current go the opposite direction. With direct current, it might look something like this. And please do forgive my bad setup. So the current will flow like this during direct current, meaning one way. Should you flip the two wires, it would be reversed, and the current would flow the other way. Some DC appliances might work anyway, like certain motors might just go the opposite direction. Others would break, others would not work at all. It depends, but with alternating currents, the current flows forwards and backwards several times. So it really just is direct currents, but then flipped, and then flipped again, and then flipped again. So what happens when you switch the two wires at the terminals here? Well, you get alternating current, and the appliances don't know the difference. That's why 230 volt AC appliances with this type of plug don't care what way you insert the plug into the sockets. I know certain plugs like UK plugs can't be flipped around because of the earth pin, but should we, for example, flip them around like this at the sockets or inside the socket, the appliance would still work. So if reverse polarity isn't an issue for these AC appliances, then why make a video about it and hint that there could be problems? Well, that's because the issue isn't where the socket is or the actual plug. That part can be reversed. The appliance doesn't care. The potential danger arises when you have reverse polarity where your miniature circuit breakers or fuses are inside the consumer units or before the consumer units. That's to say the wires going into the consumer units. Sorry for the blurry picture, but here. In Swedish homes you normally only fuse the line, which is here, the brown, the black and the grey. Sometimes it might just be brown, but anyway, every single miniature circuit breaker has one wire. This is the case for a lot of other countries in the EU as well. So what happens when the miniature circuit breaker, or MCB, is flipped on is that current can, for lack of a better word, flow all the way to the socket. So we've got 230 volts AC between line and neutral, and 0 volts between neutral and earth. As you can expect, if we flip it off, we'll have 0 volts between line and neutral, and also still 0 volts between neutral and earth. The reason we haven't got a potential difference or voltage between the neutral and earth, even if the MCB would be flipped on, is because they are essentially the same. Let me show you. To make things simple, I'm going to ignore the other phases and just go with phase 1, or line 1, which is the brown wire, neutral and earth. Sometimes you've got 5 wires, or in this case to make things simple, 3 wires coming into the house. Here we've got both the neutral and the earth coming from the transformer all the way to the house. And sometimes you've got 4 wires, which looks like this. Here the earth wire is combined with the neutral wire all the way until it reaches the house where it separates. But it does not matter if the connection point between these wires happen at the house or at the transformer, like with the first example. They still have 0 volts between them. They are sort of the same, except they have different jobs. So this means that there's still 230 volts between neutral to line, and 230 volts between earth and line. Might be confusing why I'm mentioning this even, but it will make sense soon, hopefully. Okay, let's go back to this picture for a second. As I'm sure you know, there is 0 volts between line and neutral when the MCB is flipped off. But should we reverse polarity this situation, or flip the line and neutral wires before the MCB, like here, then yes, we would have 0 volts between line and neutral, because here the neutral is of course disconnected, so the current can't get back to the transformer, and also 0 volts between neutral and earth. But there would be 230 volts between line and earth, because here the line is not disconnected, nor is the earth, because we don't disconnect the earth normally. All we've done is make it 0 volts between line and neutral. So there is still a danger here should you decide to do some work and think that, oh well, I've flipped the miniature circuit breaker, I can work here. You can still very much get shocked between the earth and the line, or if you're touching line and standing on earth. So this is why we fuse the line and not just the neutral. And we don't have to worry too much about reverse polarity when it comes to house installations like this. I think one of the reasons is because it's a fixed installation. Your neutral and line wires aren't just going to suddenly swap positions by themselves. But this could happen in a camper quite easily. Let's take a look. I've made a very simplified version here, so please don't mind the fact that I haven't got a main breaker or switch here. If you look inside the consumer unit inside the van, you can see I've wired it in a similar way you might wire things in a house. Don't install it this way in a camper. It could work if you were to take a multimeter and also know how to use it, and then test the main socket you plan on getting your power from, this socket. If you can determine which one is line and which one is neutral, then you can plug in your adapter accordingly, this adapter, and provided you know which one is line and neutral on your own camper's electrical inlets, then you could be safe and good to go. This is annoying though, having to do it this way. So instead of checking every single time with a multimeter, it'd be a lot easier if you just didn't have to worry about it. And I'll show you how in just a bit, but before that, just in case you were thinking that you can't run into this issue at a campsite using their camping outlets, just because the earth pin is a bit thicker or thinner, so the actual plug will only fit in one way. You don't know who installed it, or with 100% certainty how it was installed. So it's still a 50-50 gamble which one is neutral and which one is line, or hot as Americans say. The same goes for an inverter, which is a device that will convert or transform your 12 volts DC or direct current to 230 volts AC or alternating current. It doesn't have to be necessarily 12 volts, depends what your battery system is and what your inverter is, but as an example. Unless you yourself have tested, so you know which one is line and which one is neutral, you don't know. So test beforehand before installing it into your consumer unit, or better yet, don't install it in this way using one-pole miniature circuit breakers or MCBs where reverse polarity becomes an issue. These are easy to recognize, one terminal at the top and also at the bottom. Instead, you want to fill your consumer unit with these devices. These are all two-pole components. The RCD on the left there, followed by 4 two-pole MCBs. To flip one side is to flip both sides, but not just externally. Internally, they also trip together. When one trips, the other one does so as well, should there be a short circuit or overcurrent. This means that both the neutral and line, or hot, get disconnected, and therefore it doesn't matter which one is which or if you get reverse polarity. Both wires are fused, and both will be disconnected if you should choose to turn it off manually and do some work. But don't confuse this with using two single pole breakers together. That's not the same thing. Because if you take these two and connect the neutral to one, the line to one, and use a small hole there, or those small holes, drill right through there and put like a little metal pin in between to like conjoin them, they won't work as a two-pole breaker. I mean, sure, you can manually flip them both and know that they have both been disconnected if you want to work on the system. But if one should trip because of overcurrent or a short circuit, don't expect the force of one tripping to be able to pull the other one with it. Also, if you decide to get a consumer unit with these components inside, make sure you get the right stuff. For example, my RCD is just an RCD, meaning that 40 amp there doesn't mean that it will disconnect because of overcurrent at 40 amps. It just means that this RCD is designed to handle 40 amps max before perhaps getting too hot or damaged. Now, to be even more safe in my case here, I would want to add another MCB between the RCD and the other MCBs. Sorry, I know it's really messy right now, but from the bottom of the RCD, you've got two wires going into the bottom of the first MCB, out the top, and then they fold down all the way to the second MCB's bottom, where they then get stringed together to the bottoms of the other MCBs. Anyway, basically what we want is something that will trip should the total current of all the other smaller MCBs and their appliances exceed the limitations of the RCD or the wires going into the RCD. A bit like a main fuse. And I suppose it doesn't have to be installed between there, it can be installed before the RCD as well, as long as it trips before the RCD breaks or the wires burn up. Truth be told, you might actually want an MCB where I've put it here, if your run is very long before it gets to the consumer unit. Or just have the consumer unit really close to the inlet. You want to protect every single long stretch of wire, because you never know, the socket or outlet you might connect your camper to could potentially be perhaps not fused. I mean, it should be, but you never know. or maybe the fuse is, or the MCB is rated higher than your wires are. For example, say that socket is fused to 16 amps and you're only using 1.5 square millimeter wire. That means that your wire is the weak link in that chain, and basically the fuse. As a final note, if you're going to do it this way with 2-pole, which you should in a camper, you want to have all your components be 2-pole. Like for example this relay, I've got it for the water heater. You don't necessarily need relays in your installation, but I have in mine for a few reasons, and this one cuts both the line and the neutral. That was all, thanks for watching.